Hey, pre-algebra, we're still in chapter 1 and we're looking at section 5. We're looking at words, tables, equations, and graphs. Our vocabulary is as follows: function, function rule, function table, and equation. So a function is defined as a relation where each member of the domain is paired with exactly one member of the range. There should be a period there. So we can take a look at an example. So here's a relation. Okay, if you take a look at this relation, you'll notice that each member of the domain, and I'm going to underline those members of the domain in blue. We remember that the domain is the set of all x values. Each member of the domain is mapped to exactly one member of the range. So 2 is mapped to 3, 4 is mapped to 7, 5 is mapped to 3, 1 is mapped to 0, and 0 is mapped to 0. It's okay that the members of the range have been, well, repeated, like 0 and 0, for instance, or 3 and 3, but the domain members cannot be repeated. A domain member cannot be joined with more than one range member. Let's look at a different example. When checking out this next relation, we see that 5 is mapped to 2, 3 is mapped to -1, 6 mapped to 1, 4 mapped to 0, 5 is mapped to -3. Do you guys see the problem? I hope you do. 5 has been mapped or paired with two different items, and therefore this is not a function. You are not a function. You're not at all. All right, and this is a function. Yes, function. This one up at the top is a function, and the one at the bottom is not a function. All right? So sometimes our functions, well, oftentimes our functions have rules associated with them, and so we'll take a look at an example. So in this case, this should really read, there we go. So a function rule is the operation or operations performed on the domain value to get the corresponding range value. So let's take a look at an example. Here we have a relation and we have it set up in a table. 3 is mapped to 5, 4 is mapped to 7, 5 is mapped to 9, and 7 mapped to 13. We notice every element of the domain, right? We remember all of those x values are part of our domain. Every element of the domain is mapped to a unique element of the range. So yes, this is a function. And now let's think about the rule. What did it take for me to start with 3 and get 5? And it has to be the same thing for each element. So what did I do to 3 to get 5? I have to have done the same thing with 4 to get 7, 5 to get 9, and 7 to get 13. Can you see it? Can you tell? Think about it. Think about it. And pause me and unpause me now. And so now what you have, hopefully you see that 3 times 2 minus 1 will give me 5. And that relationship will happen all the way down the line. 4 times 2 minus 1 gives me 7. 5 times 2 minus 1 gives me 9. And then 7 times 2 minus 1 will give me 13. So what does that mean? How do I write that? Well, I will write, I'm going to take 2 times the input value or the x value, I'll subtract 1 and I will get y. So oftentimes functions have rules that can be written like this, like an equation. A function table is exactly what you saw in the last example. It's a table that lists x coordinates or the inputs and the function rule and then the y coordinates and the output. So we'll write it again a little bit more straightforward. So instead of just having x and y in your text, they choose to put the equation in the center. So when we talk about a function table, oftentimes the equation will be right in the center like this. So if we go back to the values that we had last time, I think they were 3, I don't remember actually, 3, 4, 5, 7, something like that. If we plug these values in, we would write, to show the work, we write 2 times 3 minus 1 equals, and what do we get? 5, and then we could put the 5 over here, and we continue down with that process. So that's what a function table looks like. An equation is basically a math sentence that states that two things are equal. The key here is that whenever you have an equation, you're going to see an equal sign. So if you have a math sentence, 4x is equal to 2, this is an equation. Anytime there's a math sentence with an equal sign, it's an equation. No equal sign, not an equation. So we've come to our first example. Example 1 says make a function table. Make a function table with 4 inputs and output values for the following statement, then state the domain and range. So we're going to do just that. We remember from our definition that a function table, according to our text, looks like this. So we rock an X here, that's going to be my input, Y is out here, that's my output, and then we need to make the rule to represent this right in here. And so it says triple a number, then decrease by 1. So that is 3x minus 1, and that's going to give me y. So my input is x, I put that number in, I triple it, I subtract 1, my output is y. Okay, so when it says choose 4 values, all you have to do is choose 4 values, any values that are convenient. We can do 0, 1, 2, and 3. Those are 4 values. I'm going to plug it in and check out what the y value is. So when I take 3, multiply it by 0, and subtract 1, I get -1. When I take 1, multiply that by 3, subtract 1, I get 2. When I take 3, multiply it by 2, and subtract 1, I get 5. And finally, when I take 3, multiply it by itself, and subtract 1, I get 8. So my output values are -1, 2, 5, and 8. But the text asks us another question. It says, state the domain and the range. And the domain, I'm going to write it over here in red. The domain, use a capital D for this set, is the set of all numbers. What numbers? 0, 1, 2, and 3. Remember, the domain is all the x values. And the range, I'll continue with this color, is equal to the set of these numbers, -1, 2, 5, and 8. Our next example has 2 parts. We're going to use multiple representations, so we'll take it one part at a time. Let's first look over both parts. The navigation message from a satellite to GPS in an airplane is sent once every 12 minutes. Write an equation to find the number of messages sent in any number of minutes, and then make a function table to find the number of messages in 120, 180, 240, and 300 minutes. Then we're going to graph those ordered pairs. So let's look at the first part. So we're going to write this equation, and you notice we're talking about any number of minutes. So that's where my variable is going to come from. So let's let m equal the number of minutes. And if we do that, and we recognize that we are only going to get one message for every 12, we want to figure out how many, for every 12 minutes, we want to figure out how that works out. Our knee-jerk reaction might be to do 12 times m, but when I think about these types of problems, sometimes I have to put a number in mind for myself. So I put a large enough number. So let's say, what if m was equal to, I don't know, 240 minutes, right? What if, this is, I'm going to put it in a thought bubble because it's not actually an answer. It's just something I'm thinking about. So what if the number of minutes was 240? How many messages would be sent? Would I take 240 and multiply it by 12? My hope is that you guys see that that doesn't work, that you would take 240 and divide it by 12, because for every 12 minutes, there's one message sent. With that in mind, let's get rid of that thought and deal with the problem at hand. So if m were 240, I divide by 12. It doesn't matter what m is. I'm still going to have to divide by 12. So m divided by 12 is equal to the number of messages. And I'm going to let y represent the number of messages. Okay. All right, so here we have m divided by 12 is equal to y. I want you to keep that in mind. That was from part A, so now we're going to attack part B. It says make a function table to find the number of messages sent during 12, 180, 240, and 300 minutes. Then we're going to graph our ordered pair. So let's make that table. So our chart looks like this, where m is our input, m divided by 12 equals y is our rule, and y is our output. So if I go through and use the rule, I'll see that I get the following values. 120 divided by 12 is 10, and 15 when I divide 180 by 12, I said 120 divided by 10 is 12. I don't know, 120. Anyway, you see what I have. What I have is right, even if what I said was a little off. And then so my inputs are as follows and my outputs are as follows. So here are my inputs, that's my domain, and here's my outputs, that's my range. Now to get to the final part, which is to graph the ordered pairs. This is always a little bit tricky, and the reason why it's tricky is because these are some pretty large numbers and we have limited space. So this is where it's necessary to be creative and to use your math facts with your multiplication skills. We know we need to get all the way up to let's use not an eraser for that. We need to get all the way up to 300 on the x-axis, and we need to get up to 25 on the y-axis. And I know that we're using the variable m, but our input always goes on the horizontal axis, and our output generally goes on the vertical axis. So let's see if we can number this in a way that will be helpful and meaningful. As I observe the terms in the M column, I recognize that all of those numbers really seem like they're multiples of 60, and that was a convenient way for me to number that axis. Let's do the vertical axis now. You probably would have done exactly the same thing, recognizing that all these y terms are multiples of 5, so I counted by 5s up. It's totally legal, doable, logical to change your numbering on each axis, but you cannot change it from the negative to positive sign. So if I'm going to label it by 60s on the right side, I've got to do that on the left. If I'm going to label it by 5s going up, I'm going to have to label it by 5s going down. All right, so now we're just going to plot the points. As I plot the points, I notice, well, that wasn't really a beautiful point. I apologize, my friends. I'm hoping that your graph looks much better than mine. As I plot these points, I notice that they all lie in a beautiful straight line. I could describe this graph as a linear graph because everything lies on a straight line, and looks pretty good. Hopefully you got the same thing. All right, good people. So you see your assignment for tonight. Or your assignment that you should be able to do by tonight. And of course, you can work on it in class tomorrow. So we're just working on pages 35 to 37, 4 to 18 all. Have an excellent night, and I'll see you guys tomorrow morning.